Hi students, good evening. Okay, so we'll start with the session. So we're in the fifth session of work, energy and power chapter. இன்னைக்கு என்னன்னா we'll discuss about the concept of potential energy and modified work energy theorem. So என்னன்னு நம்ம பார்க்க போறோம். So we are going to look at what the concept of potential energy. So potential energy என்னன்னு சொல்லிட்டு எப்படி வருது, what is the expression for the some common types of potential energy that we will consider. Okay, and madri we'll also talk about the modified work energy theorem. Okay va? So first when we look at the potential energy concept, already on the energy terms discussion la we talked about it, that potential energies are related to what? Conservative forces. So if you look at work done by a conservative force, right, we talked about two properties. Another, work done by a conservative force in a closed loop will be zero. அது ஒன்று. ரெண்டாவது, work done by a conservative force does not depend upon the path. பாருங்க, ஒரு பொசிஷன் ஏல இருந்து we are moving an object up to position B. So whatever path you take, நம்ம இந்த path எடுக்கலாம், or you can take this path, whatever path you take, the work done by the conservative force மட்டும் will be what? It will remain the same or constant. Means என்ன தெரியுமா, work done by the conservative forces depends only on the position or the state. So what is the initial position, what is the final position, அவ்வளவுதான். It does not depend upon the path taken. Based on this understanding, whenever we look at the movement of an object or movement of a body, right, if work done by the conservative force is not dependent upon the path, so path மேல depend ஆகலன்னா, then we don't need to calculate the work done by the conservative force each and every time. திருப்பி நம்ம இந்த வேல்யூ கால்குலேட் பண்ண வேண்டாம். அதுக்குன்னு சொல்லிட்டு there is an different idea that is designed. That idea is what we call as the potential energy method. What is that idea going to be called as what? Potential energy method. So that is the reason why we will say potential energy is not a real form of energy. It is associated with the conservative force. எப்படின்னு சொல்லிட்டு we will look at it. Like the way every object we said it will have one real form of energy, அது என்னது? kinetic energy. அந்த மாதிரி we will say that depending on the position or the state, the object will also have one more type of energy called as what? Potential energy, which will be related to the conservative forces. So depending upon the position or state of that object, the object will have one more type of energy which is called as what? The potential energy. The potential energy, right, will be related to the respective conservative force. The potential energy will be related to the respective conservative force. எப்படின்னு சொல்லிட்டு we look at it. So how the relation between the work done by the conservative force and potential energy will exist. Okay, பார்க்கலாம். So we'll look at what is this idea of the potential energy. See, what is the normal work energy theorem? Work done by all the forces acting on the object is equal to change in kinetic energy. இதுதானா? So work done by all the forces and சொன்னா இதில் there will be conservative force இருக்கும், அந்த மாதிரி there will be non-conservative force also. Work done by all the forces சொன்னா other there will be some force like gravity இருக்கும், which is a conservative force. There may be a force like friction also, which will be non-conservative. So இப்போ நம்ம என்ன எழுதலாம், we can write it like what? Work done by all the forces means some of the forces may be conservative, some may be non-conservative. So we are splitting them up. So work done by the conservative forces plus work done by the non-conservative forces, that will be equal to what? Change in kinetic energy. Okay, so this is the normal work energy theorem that we have already studied. இப்போ என்ன தெரியுமா, we are going to discuss about a new energy form that the object will have. What is this energy form? We are calling as potential energy. What is the energy form? We are calling it as what? Potential energy. So main purpose of potential energy என்ன தெரியுமா, the potential energy term is defined such that it will account for, what is the main purpose of the potential energy term? It will account for work done by the conservative forces. ஏன்னா இந்த potential energy concept நம்ம உள்ள கொண்டு வந்தா அதுக்கப்புறம் we don't need to consider the work done by the conservative forces. ஏன்னா அது already இதில் included. The work done or the impact of the conservative forces, right, is already included in terms of the potential energy. அதனால தான் for every conservative force we will have a corresponding potential energy term. So potential energy term will not be coming for the particle separately. It is always linked to the respective conservative force. That is the way we say what? Gravitational potential energy, spring potential energy, and electrostatic potential energy, magnetic. So it will be always related to what? The corresponding conservative force. What is the relation? We will see. Now once we assume that the object is now having potential energy also, right, we will not be considering the work done by the conservative forces. ஏன்னா அது already that is accounted in the potential energy termலே வரும். So இப்போ பாருங்க, when an object is moving from state A இருந்து state B ன்னு வெச்சுக்கோங்க, initial state to final state, it will have a change in the kinetic energy, and it will also have a change in the potential energy. The object will be having what? Change in kinetic energy and change in potential energy. Now the work done by, we will only look at the remaining forces. What are the remaining forces? Veru non-conservative force mattumdana. Work done by the remaining forces will be equal to what? Inga enna varum parunga, change in kinetic energy varum plus change in potential energy. So idu eppadi theriyuma, initially we will say what? The object will have kinetic energy and potential energy. We are looking at the work done by the non-conservative forces. Adilundu we will get what? Final kinetic energy and final potential energy. So paranga, what is the relation we will have? Work done by the non-conservative force is equal to what? Change in kinetic energy, which is final kinetic energy minus initial kinetic energy plus change in potential energy. Okay va? So this is what is the modified work energy theorem. So what is this statement going to be called as from now onwards? Modified work energy theorem. Idu enna theriyuma, and the conservative forces mattum we will not include. Because the work done by the conservative forces is already adjusted in the potential energy term. எதில் நம்ம அதை adjust பண்ணிருக்கோம்? Because each and every time, so whatever the path, right, the potential energy will only depend upon the positions, initial and final. Work done by the conservative also depends upon the initial and final positions தானா, பாத்துக்கு மேல depend ஆகாது. So that is how we are able to link the potential energy term to the work done by the conservative forces. அது எப்படின்னு சொல்லிட்டு we will look at it. So now in one more step we will be able to see what is the exact relation between the potential energy term and work done by the conservative forces. பாருங்க, அப்படியே நீங்க அந்த ஈக்குவேஷன் என்னது, இது equation 1 and equation 2 ன்னு சொல்லலாமா? பாருங்க, so let us call it as what? இது என்னது equation 1 ன்னு வெச்சுக்கோங்க, இது என்னது equation 2. இந்த ரெண்டு ஈக்குவேஷன்ஸ் நம்ம கம்பேர் பண்ணா என்ன வரும் பாருங்க? Work done by the non-conservative forces, right? அப்படியே நீங்க இந்த வேல்யூ சப்ஸ்டிட்யூட் பண்ணுங்க. சப்ஸ்டிட்யூட் பண்ணா work done by the conservative forces plus change in kinetic energy plus change in potential energy is equal to what? Right side la அப்படியே இந்த வேல்யூ மட்டும் we are substituting the equation 1. இதில் சேஞ்ச் இன் கைனடிக் எனர்ஜி டேர்ம் கேன்சல் ஆகிடும். ஸோ ஒர்க் டன் பை த கன்சர்வேட்டிவ் ஃபோர்ஸஸ், சேஞ்ச் இன் பொட்டன்ஷியல் எனர்ஜி we will take it to the right side. அப்போ என்ன வரும்? மைனஸ் வரும். நெகட்டிவ் ஆஃப் சேஞ்ச் இன் பொட்டன்ஷியல் எனர்ஜி. ஸோ என்னது? வாட் இஸ் த ரிலேஷன்? ஒர்க் டன் பை த கன்சர்வேட்டிவ் ஃபோர்ஸஸ் இஸ் ஈக்குவல் டு வாட்? நெகட்டிவ் ஆஃப் சேஞ்ச் இன் த பொட்டன்ஷியல் எனர்ஜி. இதை நம்ம இன்னொன்று விதமாக சொல்லலாம். எப்படி? நெகட்டிவ் ஆஃப் சேஞ்ச் இன் தி ஆர் நெகட்டிவ் ஆஃப் ஒர்க் டன் பை த கன்சர்வேட்டிவ் ஃபோர்ஸ், அப்படியே அந்த மைனஸ் இந்த பக்கம் எடுத்துகிட்டு வரலாம். நெகட்டிவ் ஆஃப் ஒர்க் டன் பை த கன்சர்வேட்டிவ் ஃபோர்ஸ் இஸ் ஈக்குவல் டு வாட்? சேஞ்ச் இன் பொட்டன்ஷியல் எனர்ஜி. இப்படி சொல்லலாம். So this is how the potential energy term is going to be defined. இப்படி தான் நம்ம டிஃபைன் பண்ண போகிறோம். ஏன்னா potential energy is not a real energy. It is defined by using what? By using the conservative forces. It is defined by using what? Conservative forces. Okay va? So what is the relation? Work done by the conservative forces is equal to what? Negative of change in potential energy. Illana we can write it other way also. What is the other way? Negative of work done by the conservative forces is equal to change in potential energy. In the relation based panida, we are going to derive the gravitational potential energy formula and the madri the spring potential energy formula. Idella enga irundhu varum? All the formula are going to come from this relation. What is it? Work done by the conservative force is equal to what? Negative of change in potential energy term. Illana we can write the other way. What is it? Negative of work done by the conservative force is equal to what? Change in potential energy term. இப்படி நம்ம எழுதலாம். Okay, this is very important. This is how we are defining the potential energy term. இப்படி தான் நம்ம define பண்ணிருக்கோம். This is how we are defining the potential energy term. Okay வா? பாருங்க, a potential energy of a body in position A எவ்வளவு? -40 joules. Okay வா? Work done by the conservative force in moving the body from A to B is what? -20. So என்ன கொடுத்திருக்காங்க? Work done by the conservative force எவ்வளவு? -20 joules. Potential energy of the body in position A. Generally என்ன தெரியுமா? We will use symbol U. You can use symbol P also, or we can use symbol U, whichever you are using. Okay. UA எவ்வளவு? -40 joules. Find potential energy of the body in position B. Potential energy of the body in position B எவ்வளவுன்னு சொல்லி கேக்குறாங்க. What is it? UB. We need to find what is the UB ஓட value. எப்படி வரும்? How we are relating the potential energy to the work done by the respective conservative force. எப்படி நம்ம relate பண்றது? What is it? Negative of work done by that respective conservative force is equal to what? Change in the potential energy. அப்படிதானா? So பாருங்க, we are moving from A to B means change and so now what is it? Final potential energy minus initial potential energy. So negative of work done by the conservative force means minus of -20 varum is equal to what? UB minus UA எவ்வளவு? -40. இப்போ பாருங்க left hand side இருக்க minus into minus இது plus ஆயிடும். UB இங்கே அப்படிதானா? minus into minus will be what? Plus. இப்போ நம்ம 40 left side எடுத்துட்டு வந்தா it will become what? Negative தானா? So 20 minus 40 எவ்வளவு? -20. இதுதான் UB ஓட value. So what is the potential energy at the point B? -20 joules. புரியுதா? So this is how the potential energy term, it is not, see, it is not for a particle. இப்போ kinetic energy சொன்னா it is for a particle, it is for an object. But potential energy அப்படி கிடையாது. It is for the interaction of that particle with the respective conservative force. So that is why we will not say the potential energy of that particle. It is potential energy of the interaction between the particle and the respective conservative force. Okay va? Adukana what is the relation? Negative of work done by the conservative force is equal to what? Change in potential energy. So this is the relation between work done by the conservative force and the corresponding potential energy term. Okay, so inga we look at the modified work energy theorem one more time. Enna ippolund enna theriyuma? We are going to use this modified work energy theorem enna for all the conservative forces, right? Like gravitational force agatum or spring force agatum. For now in mechanics, at the stage when we go to the electrostatics and magnetism, right, there we'll talk about again the electrostatic potential energy and the magnetic potential energy adella varum. Okay, but in terms of the mechanics we will look at gravitational potential energy and then spring potential energy. So for these forces, right, we have already defined the potential energy term நம்ம define பண்ணிருக்கோம் வெச்சுக்கோங்க. Then the work done by the other forces சொன்னா typically they are what, non-conservative forces or the external forces other than the conservative forces, right? ஏன்னா conservative forces அதோட impact is already adjusted in the potential energy term அதுல வந்தது. So அதனால work on சொன்னா we are going to look at only work done by the non-conservative forces or the external forces, anything other than the gravitational or spring, ஏன்னா அதோட impact is already adjusted in the potential energy term. பாருங்க, this will be equal to change in kinetic energy of that particular object plus change in potential energy. Change in potential energy ன்னு சொன்னா தனித்தனியா வரும். If there is a gravitational potential energy வெச்சுக்கோங்க, it will include what, change in the gravitational potential energy. Along with that we are also having spring potential energy, then we also have to include what, change in the spring potential energy. Maximum case la ஒரு value தான் வரும், but sometimes we can have both the things, potential energy change agala and மாதிரி the spring potential energy also can change. In some really complicated questions, right, we can also have this electrostatic potential energy also. So angana we have to consider change in the electrostatic potential energy. So depending upon what are the conservative forces involved, என்னென்ன அதுல இன்வால்வ் ஆயிருக்கோ அது மட்டும் we have to consider. ஓகேவா? So this is about the modified work energy theorem. So இதுக்கப்புறம் என்ன தெரியுமா, most of the problems இந்த ரிலேஷன் தான் நம்ம யூஸ் பண்ண போறோம். There is already one basic form. Basic formula என்ன, left side work and சொன்னா we are including work done by all the forces. What is the basic form of the work energy theorem? Work done by all the forces is equal to change in kinetic energy. This is what is the basic form of the work energy theorem. இப்போ நம்ம பார்க்கிறது என்ன, modified form. இதுல we are adjusting for the work done by the conservative forces by using the potential energy term. எப்படி நாம இந்த adjustment பண்றது, the work done by the conservative forces is related to the potential energy term. எப்படி, negative of work done by the conservative forces is equal to what, the change in the corresponding potential energy term. In the relation base பண்ணி we are able to adjust. Okay va? So this is what is the modified work energy theorem. இது base பண்ணி we will try to solve some questions later. Okay va? இப்போ என்னன்னா we look at how do we derive the potential energy for the gravitational force. இங்க என்னன்னா we are going to look at the simplified form of the gravitational force. Simplified form of the gravitational force ன்னு சொன்னா we will look at what, this mg. பாருங்க, from the surface of the earth லந்து we are taking the object by giving it a vertical displacement h. So surface of the earth லந்து we are taking it to a vertical height h. Okay va? So then the initial stage, the final stage. Okay, gravitational force எப்படி act ஆகும், downwards தானா, gravitational force எப்படி, it will be downwards. So we will take this to be almost constant. ஏன்னா if the height is not very large, right, so gravitational force will be almost constant. ஏன்னா g change ஆகாது, acceleration due to gravity oda value அந்த அளவு change ஆகாது. That's why we consider it as what, constant. We can take it as what, constant. இது நம்ம constant எடுத்தா then we are looking at what, the simplified formula for the gravitational force. திருப்பி when we go to the gravitation chapter, right, அங்க என்னன்னா we look at the original gravitational force formula. அது பேஸ் பண்ணி we will derive the potential energy one more time. இங்க என்னன்னா we are looking at what, the simplified gravitational force formula mg. ஓகேவா? இப்போ பாருங்க, initial surface of the earth லந்து we are taking the object by giving a vertical displacement h. So the angle between the gravitational force and displacement என்னது, displacement is upwards, gravitational force எப்படி downward இருக்கா. So work done by the gravitational force, பாருங்க, work done by the gravitational force எவ்வளவு, force is what, mg, displacement h into cos 180 வரும் minus mgh. இது ஆல்ரெடி நம்ம பார்த்திருக்கோம். what is the potential energy concept? Remember, negative of work done by the conservative force is equal to what? Change in potential energy. Idana negative of work done by the inga nama discuss pannadhu patti gravitational force paddana. So that is the conservative force here. Negative of work done by the conservative force is equal to what? Change in potential energy. Change in potential energy sonna the final state potential energy minus initial state potential energy. Paranga minus minus cancel aidum. So enna varudhu namakku potential energy in the final state, which is at a height h, minus potential energy on the surface is equal to what? Mgh. So enna theriyuma, whenever we are looking at this definition of the potential energy, on the definition landu we will not be able to get what is the actual potential energy value. Actual potential energy value namakku varadu. We will only get what? The difference in the potential energy. On the definition based panni, and on the definition paranga oru thadava, what is it? Negative of work done by the conservative force, the gravity agatum or spring force, whatever it is equal to change in the potential energy. So straight namakku adilandu we will not get the potential energy at a particular state. Adu varadu. We will always get what? The difference in the potential energy da varum. Adanal enna, for all the potential energies, right, we will take something called as a reference state. Enadi, for all the potential energies we will take something called as what? Reference state. Ingane theriyuma, for the simplified gravitational potential energy formula, we will take the surface of the earth as the reference, where we will take the potential energy 0. So surface of the earth is taken as what? Reference. Anganade, we are saying the potential energy of the object is what? 0. Apadi nama edutha, so this we are taking as what? 0. This is reference. And na sonna madri, for all the potential energies, right, we will have a reference. Inganade, for the simplified gravitational potential energy formula, what is the reference we are choosing? Surface of the earth. So we are taking the surface of the earth, potential energy evola 0. Apadi edutha paranga, remaining is what? Potential energy of the object when it is at a height h, evoladu? Mgh. So this is what we are going to use. So if object is not going up, it is going down vechukonga, then this h we will have to record as a negative. In a surface length, what is the understanding we are having? We are taking it up. Okay, surface length, if you are going down, then ingane theriyuma, this h value we have to take as the negative. The h value we have to take it as what? Negative. Okay, which means if you look at the positions above the surface of the earth, for any object, the gravitational potential energy will be what? Increasing. If you look at the positions above the surface of the earth, the gravitational potential energy will be what? Positive. If you keep going up and up, means potential energy will be increasing. If you are going below the surface of that, means potential energy will be becoming negative. In the formula we are going to substitute h as what? Negative. We will substitute the h value as what? Negative. So the potential energy is going to become what? Negative. Okay, so this is what is the simplified gravitational potential energy. Is that our maximum use panna porom in terms of mechanics problems, right? This is what we will be using. Okay, so if you take the surface of the earth as the reference, from there you go to a height h, means potential energy, the potential energy at a height h is equal to what? Mgh. Okay, one of the other doubt that we'll have, for a extended object and sonna, it is not a point mass like a block or a cylinder, something which is extended like a chain or something. Here we said the object is at height h, right? Inga paranga, if you look at this block, in the block eduthu paranga, so look at this block, different parts of the block, and neenga oru block nu sonna adula nariya particles irukum. Different particles of the block will be at different heights from the surface of the earth. Surface of the earth la neenga height measure panna, different parts of the block will be a different height. Appa enna theriyuma, we will have to consider the potential energy by using, if it is a symmetric object vechukonga, if it is a symmetric object, okay, if it is symmetric object, we can easily find what is the center of mass. Okay, center of mass and we will discuss about it later. But for the symmetric objects enna theriyuma, the geometric center, for the symmetric objects, the geometric center is where we will have to assume the potential energy to be calculated from. Means inga parunga, if this geometric center is at a height h, then the potential energy, ipo idoda mass m nu vechukonga, the potential energy of this block will be what? mgh. So we will calculate the height by using what? Geometric center. For the symmetric objects, we will calculate this potential energy by using what? The position of the geometric center. Okay, if you have asymmetric objects is another which is not symmetric, like irregular shape, we will see, I mean, when we go to the next slide, in the center of mass concept, when we go to that particular idea, then we will see, okay, how we will be able to find out the gravitational potential energy of the objects when the objects are irregular. So in maximum we'll have what? Symmetric objects like the block and the mother varum. So for these, right, we'll have to look at what is the, for the symmetric objects, the geometric center adoda height, right, that is what we have to consider for the calculation of the gravitational potential energy. Okay va, inga parunga, this is an interesting question. A chain C of mass m and length L is held in the position touching the ground as shown. Eppadi, idoda length evlo L, it is held like one end is touching, keela irukra end is touching the ground. If it is falling onto the ground fully, apdiye fully it is coming and falling, what is the change in the gravitational potential energy? So they are asking what? Change in the gravitational potential energy. Inga parunga, what is this object actually? It is a extended body. Chain and so on, what is it? It is not like a point mass. It is a point mass kadiyadu. So adoda geometric center enga irukum for a chain, assuming it is like uniform chain, right? Geometric center enga irukum midpoint dana. So which means geometric center is at a height L by 2. Enga irukka geometric center? It is at a height L by 2. So initial potential energy of the chain evala, adoda mass m anu kuduthirukanga. So m into g into what is the height of the geometric center above the surface of the, isn't a surface of the earth? What is the height of the geometric center above the surface of the earth? L by 2. So the initial potential energy evala? M into g into L by 2. Okay va? Final potential energy another, because this chain is fully falling on the ground, means what? Fully enga, it is on the surface. So geometry center angadana, geometry center is also on the surface. So final potential energy is 0, because the entire chain is on the surface. Any object which is on the surface of the earth, the potential energy as per our reference is what? Gravitational potential 0 dana. So final potential energy is 0. What they are asking? Change in the gravitational potential energy. Change in gravitational potential means what? Change means what? Final value minus initial value. So what is it? Minus mg into L by 2 is the change. Prida. So if you have an extended body, major and we will have symmetric objects like in the madri chain kurta, other geometry center will be what? Midpoint dana. If they are giving a block, geometry center is what? Midpoint. Or uniform triangular shape kurta, it will be what? If they are giving us the say equilateral triangle kurta vechukonga, then the centroid will be the geometric center and the madri. For a square agatum or I mean for anything, right, we will be able to see what is the geometry center easily. Adi easy na geometry center nam easy identify pannala. For the symmetric objects, right, we have to take that gravitational potential energy calculation is based upon what? Adoda geometric center height from the surface of the earth. Okay va? So if it is asymmetric or irregular shape means we will discuss about it when we go to the system of particles concept, right? அங்க நம்ம அதை பத்தி டிஸ்கஸ் பண்ண போறோம். Okay, so this is about the concept of the gravitational potential energy. So taking the surface of the earth as a reference, the potential energy of the object which is at a height h above the surface of the earth எவ்வளவு? mgh. நீங்க கீழே போனா surfaceல இருந்து if you are going down in that formula, mgh formula, you have to put the h value as what? Negative. All the difference. Okay, so this is about the gravitational potential energy. Other than that, we will go to the spring potential energy. So inga enna theriyuma, we will look at, say for example, there is a spring. Okay, there is a spring, we are trying to, so this is the natural length. So every spring will have natural length. Natural length enna theriyuma, if you just leave the spring like that, adoda length in that particular state is called as what? Natural length. Okay, so natural length anga irukra position, let us mark it as what? Idan x is equal to 0 நம்ம mark பண்ணலாம். X is equal to 0. Okay va, அங்கலந்து we are trying to elongate the spring. எப்படி? We are trying to elongate the spring so that we can see what is the amount of elongation. The natural length point landu we can see what is the amount of elongation. Okay va, so when you are elongating it, the spring force will come into picture. Spring force at nature eppadi irukum? Restoring force dana. The nature of the spring force will be what? Restoring force, which means, so nama right side nama elongate panna, the spring will try to pull us back, so it will be acting in the opposite direction. inga parunga, if we have elongated by a value x nu vechukonga, if we are already elongated by a value x, then the restoring spring force evla? It will be k times x, but in the opposite direction. It will be what? K times x, but in the opposite direction. Okay, so ingalandu we will move further by a small length dx. So we are trying to elongate it. So already we elongated by a value x, angalandu we are again elongating by some more value dx. For this small elongation, right, paranga, the displacement is towards the right side, the spring force eppadi iruka? Towards the left side. So the small work done by the spring force, ஏன் நம்ம இந்த ஸ்மால் work மெஷர் பண்ண தெரியுமா? Because spring force is a variable force, இது ஒரு கான்ஸ்டன்ட் ஃபோர்ஸ் கிடையாது. So we cannot take the work done for a large displacement, we have to take a very small displacement, differentially small displacement. அங்கல இருந்து தான் நம்ம work calculate பண்ண முடியும். பாருங்க, the work done by the spring force for the small displacement எவ்வளவு? Force is kx, displacement is x. What is the angle between them? 180, right? Cos 180 minus 1. பாருங்க, minus kx dx வருது. So இப்ப என்ன தெரியுமா? இந்த இனிஷியல் natural length position, அங்க elongation ஓட 0, அங்கல இருந்து we are slowly moving the or elongating the spring so that the final elongation is capital X. What is the capital X? And the spring oda final elongation value. Capital X enadhu spring oda final elongation value. Slowly we are moving it so that, you know, initially adoda natural state landu we are creating a final elongation of capital X. Ipo parunga, when we want to calculate what is the total work done by the spring force, எப்படி வராது? இந்த எக்ஸ்பிரஷன் அப்படியே நம்ம இன்டிகிரேட் பண்ணணும். angle in the value of the elongation initially எவ்வளவு? 0, final elongation எவ்வளவு? capital X. புரியுதா? so இப்ப பாருங்க, work done by that spring force எவ்வளவு? அப்படியே அந்த minus k வெளியே வரும், x dx. x dx integration x dx ன்னு சொன்னா what is it? x square by 2 தானா? so minus k, லிமிட்ஸ் இருக்கா? இனிஷியல் லிமிட் எவ்வளவு? 0, ஃபைனல் லிமிட் எவ்வளவு? கேபிட்டல் X. ஓகேவா? so integral x dx எவ்வளவு? x square by 2. what is integral x dx? x square by 2 தானா? so முடிஞ்சது, we are able to get the answer almost. பாருங்க, so work done by the spring எவ்வளவு? minus k into capital X square by 2 minus 0 square by 2. 0 square by 2 சொன்னா 0 தானா? minus k into capital X square by 2. இதனது? this is the work done by the spring force. remember, எப்படி அந்த potential energy definition எப்படி வரும்? negative of work done by the spring force will be equal to change in potential energy. Change in potential energy, so now what is it? Final potential energy. Potential energy when there is elongation x minus initial potential energy means what? The natural state. Initial state of the spring energy, natural state of the spring dana. So this is the relation. What we will get? The negative of work done by the spring force. What is the negative of work done by the spring force means? Already work done by the spring force namakku irukka. What is it? Minus kx square by 2. So negative of work done by the spring force is equal to what? Change in potential energy. Potential energy of the spring when it is elongated by a value x minus potential energy of the spring in the natural state. Okay va? Ipo parunga, minus minus plus side kx square by 2, or we can also read it as what? Half kx square is equal to what? Potential energy of the spring when it is elongated by a value x minus potential energy of the spring in its natural state. So already நம்ம இதுக்கு முன்னாடி டிஸ்கஸ் பண்ண மாதிரி always potential energy will have a reference. இங்க என்ன தெரியுமா? When the spring is in the natural state means neither elongated nor compressed, other natural state. Here we will take the potential energy to be 0. Is the reference. In case of the spring, what is the reference for the potential energy? We will take the potential energy of the spring in the natural state evala 0. Like gravitation case la nama enna eduthirkom, we have taken the potential energy on the surface of the earth as what? 0. Inga enadhu? Potential energy of the spring in its natural state is what? 0. Apdi edutha then we are able to get what is the potential energy of the spring when it is elongated by a value x. Evaladhu? Half kx square. Paranga, what is the potential energy of the spring? Half kx square means the potential energy will depend upon the spring property. K is what? K means what? Spring constant dana, which is a spring property. So potential energy of that spring when it is elongated by a value x, adora natural length landu when it is elongating by a value x, the potential energy evala? Half kx square. So inga paathina it depends upon the k value. K is what? The property of the spring, and also it depends upon what? X is what? The elongation value, natural length landu by how much we are elongating it. Okay va? Inga enna theriyuma? Now we have elongated, so spring oda natural length landu we can also compress it, like in the bakka. So like idukku munadi this is the natural state, right? So natural length landu நம்ம compress பண்ணலாம். So இதை நம்ம derivation பண்ண போறது கிடையாது. We will get the same answer. Okay. So potential energy of the spring when it is compressed by a value of x, அதோட natural length லந்து if you compress it by a value x, right, same value தான் வரும், half kx square. What is the potential energy when it is compressed? Same. Elongate பண்ணாலுமே or compress panna, you are going to get the same value for the potential energy. What is the potential energy value? Half kx square. So here we will see one thing. Potential energy of the spring, natural state level is 0. When it is either elongated or compressed, that will be having potential energy. What is the potential energy value? Half k into x square. So x is what? Either it is the elongation value or the compression value. Okay va? So this is about the spring potential energy. Okay, so whatever the two potential energies we are going to see in mechanics, right, adu rendu nama cover பண்ணிருக்கோம். What is it? One enadhu? The gravitational potential energy, simplified value. Second is this spring potential energy. inga parunga. So this is the question that has come in fact 2006 paper la vandhathu. Straight question. The formula base பண்ண அப்படியே நம்ம solve பண்ண முடியும். The potential energy of a long spring when stretched by 2 centimeters is u. Spring irukka 2 centimeters stretch panna adoda potential energy vala u. if the spring is stretched by 8 centimeters, நம்ம 8 centimeters stretch பண்ணா what is the potential energy stored in it? Straight question. எப்படி? So the spring constant நம்ம k ன்னு எடுக்கலாம். That should not come in the final answer. Let us say the constant value எவ்வளவு k. இப்போ initial potential energy எவ்வளவு பாருங்க, u தானா? U is what? Half into k into, initially it is stretched by 2 centimeter, means elongation எவ்வளவு 2 centimeter. So 2 centimeter square வரும். Final potential energy அது என்ன தெரியுமா? u dash ன்னு சொல்லலாம். What is it? Half into k into எவ்வளவு இங்க இருக்க, what is the stretch here? 8 centimeter, right? So 8 centimeter the square. Initially we are having a stretch of 2 centimeter. Second case ல என்ன, stretch is 8 centimeter. இங்க பாருங்க, we can divide both the equations. இதனது equation 1 வெச்சுக்கோங்க, equation 2. We will do what? Equation 2 divided by equation 1. பண்ண என்ன வரும்? Left hand side ல we'll have what? U dash by u. Right hand side ல half k into 8 square divided by half k into 2 square. இதுல half k cancel ஆயிடும். 8 square ன்னு சொன்னா what is it? 64 தானா? 2 square means 4. 4 ones are 4 16s are. இங்க பாருங்க, u dash by u எவ்வளவு? 16 வருது. Which means what? U dash is equal to 16u. அவ்வளவுதான். U dash எவ்வளவு? 16u. Just comparison. As it is based on the formula of the potential energy of the spring. Okay va, check பண்ணுங்க. So initially the stretch is what? 2 centimeter. Finally what is the stretch? 8 centimeters. So அப்படியே நம்ம அந்த formula base பண்ணி we will be able to tell. Okay, good Sanjeev Vikashini.